Right. Welcome, guys. Welcome to the logistics and manufacturing supply chain distribution. So, Unit 2, Part 3. Part 3 is going to be about plant locations. So, we'll go directly. So, what is the introduction? So, for plant location or facility location problem is an important strategic level decision for an organization. One of the key feature of conversion process is the efficiency which the product are transferred to the consumer. This fact will include the determination where to place a plant or the facility. Large investment is made in building plant and machineries. It's not advisable or not possible to change the location very often. Large forecast should be made in anticipating the future needs or the plant location. Because once, for example, any kind of automobile plant is placed, just like that, it cannot be changed to some other location due to the heavy machineries which is being utilized over there. Plant location also should be considered based on a company plan and policy, and also to have an idea how their suppliers are going to be uh, supplying the raw materials and other different third party products, how it is being transferred, how it can be placed inside the company. Every aspect should be taken into account. Plant location can affect the market and its company profit also, right? So what is the factors influencing the facility location? It is mostly about the geographic site of the firm's operation. Both manager service and manufacturing must weigh many factors when assessing the desirability of particular site, including proximity to the customer, supplier, labor cost, and transportation cost has to be taken into account. So while taking into general location factors, what are the controllable factors are, which is proximity to the market, supply of the raw material, transportation facility, infrastructure availability, labor wages, external economies, followed by the capital. These are the factors which can be taken as an controllable factors. So when you see in the non-controllable factors, government policies which tends to change at very often, climatic condition, supporting industries and services, and community infrastructure. So these are certainly uncontrollable, not completely, but to a certain extent. So what is the scope of facility layout? Related to material, less material handling and minimum transportation cost is needed. Less waiting time for in-process inventory. So this is related to materials. When you relate it to the workplace, safe working condition has to be provided, point of ventilation, lighting, etc. Minimum movement of workers, least chance of accidents or fire, etc. Proper space for machines, workers, tools, etc. So when you talk about scope of facility, these things has to be taken on top of, followed by the performance related aspects. Simpler plant maintenance has to be taken, because when you talk about a plant, it is going to be in acres. Increased productivity, better product quality and reduced cost, least setup cost and minimal change over time. Objective related to flexibility is needed. Scope for future expansion also has to be taken into consideration mainly. So when you talk about plant layout, it refers to a physical arrangement of production facilities. It is a configuration of department, work centers, equipment in the conversion process. It is a flow plan of the physical facilities which are used in the production. So according to Professor Moore, plant layout is a plan of an optimum arrangement of facilities, including personal, operating equipment, storage space, material handling equipment, and all other supporting services, along with the design of the best structure to contain all these facilities, also including the future expansion. So what is the objective of the plant layout? What is the main objective? It should reduce the material handling cost, minimize the investment in equipment, minimize overall production time, maintain flexibility of arrangement and operations, effective utilization of men, equipment, and space, provide employee convenience and safety and comfort. So how these layouts are classified? So they are classified into 5 types: process, product, combination, fixed and group layout. So if you say process layout is recommended for batch production. All machines performing similar type of operations are grouped at one location in the process layout. Example, all lathe, milling machines, and etc. Process layout is normally used when the production volume is not sufficient to justify a product layout. Typically, a job shop, employee process layout due to the variety of products manufactured and their low production volumes. So process layout is normally used for the higher production volumes. Say for example, if you are manufacturing something like a food manufacturing, which is going to happen at a higher volume rate. Say for example, you are a distillery manufacturers, you have to manufacture bottles filled with water. That is going to take a lot of time, right? So that is more like a process layout. Product layout is like layout missions, auxiliary services, which are located according to the processing sequence of the product. If the volume of the product of one or more products is large, the facilities can arrange to achieve efficient flow of materials and low cost per unit. Special purpose machines are used which performs a requirement functions quickly and reliably. The product layout is selected when the volume of the product is high, such as separate production line to a manufacturer, it can be justified. So in a strict product layout, machines are not shared by different products. Therefore, the production volume must be sufficient to achieve satisfactory utilization of the equipment. Mostly we will talk about FMS over here. Flexible manufacturing systems will be taken into account for a product layout. Say for example, any car companies, there are different variants, right? But only a single line is there. So over there, this set of layout will be executed. A combination of a process and a product layout combines the advantage of both type of layouts. So a combination layout is possible where an item is made in different types, size. Here machinery is arranged in a process layout, but the process grouping is then arranged in a sequence to a manufacturer, various types and size of a product. It is to be noted that the sequence of operation remains the same with a variety of products and different sizes. Then comes the fixed position layout. So this is called a project type of layout. In this one, the material of the major component remains in a fixed location and tools. Machineries, men and other materials are brought to this location. This type of layout is suitable when one or few pieces of identical heavy products are to be manufactured and when the assembly consists of a larger number of heavy parts. The cost of transportation of these parts are very high. When you see windmills, those erections of windmills and all is called as fixed position layout, because you have seen the wings, other parts of the windmill will be transported separately, and the position is fixed. Over there, all the materials, major components are being brought down with the men, machineries and other materials. Then it is erected over there. Followed by the group layout, there is a trend now to bring an element of flexibility in manufacturing system. As regards to variation in batch size and sequence of operation, a grouping of equipment for performing a sequence of operations on family of similar components or product has become all important. So group layout is a combination of product layout and process layout. So what is the principles of the layout? So principles of integration, how good we are integrating the with men and materials, machines and supporting services and all. Minimum distance, that is minimum travel for any material, men, employees, even the suppliers is better to consider. So principle of cubic space utilization. A good layout is one that utilizes both horizontal and vertical space. It's not only enough if only the floor space utilized optimally, but the third dimension, the height, is also utilized effectively. So the principle of flow, how of your product, your materials, your flows towards your completion stage. So there should not be any backtracking over here. So that is a example of good flow. Principles of maximum flexibility. The good layout is the one that can alter without much cost and time. That is, future requirement should be taken into account. So flexibility is a key phase over there. Safety, security and satisfaction is more needed from the employee's perspective and their working safety and standards. Principles of minimum handling, so that your material handling becomes low, where your non-value added time also comes low, which indirectly affects your cost also. So with this, we'll close up for our third part. Thank you.